I'm Nick. I'm the product manager, one of the product managers at Shoplogix, and I'll be taking you through kind of an overview of the feature. And then we also have our guest speaker here, Adam Novak from Coveris Group. Adam's the CPS and digitization manager at Coveris, and he's been the key contact who's been working on implementing this feature at his organization. And he's going to be able to share some cool insights around how it's been working at their company so far. And Adam, feel free to, if you want to introduce yourself or say a few words to the audience.
Yeah, hello everybody. So as Nick said, I'm a product owner from Coveris side of Shoplogix, when I'm responsible really for rollouts of Shoplogix in my plants, but also in some developments. And whenever there is some NFR, it's me who's kind of doing it. Yeah, and also this whole top historical speed, this was a kind of request coming from me when I was working with the Shoplogix team to redevelop it. Yeah, so yeah, that's it.
Cool, thanks, Adam. All right, then without further ado, I'll go into just covering what's on the agenda for today. So the first thing I'll go through is just a high level kind of solution overview of what this feature is all about, covering some kind of key features and benefits. Then I'm going to dive into what the feature looks like in the two kind of core parts of our platform or our product. The one being the digital whiteboard, which, as you're probably aware, is our kind of visualization engine and tool to help that's geared towards giving you visibility on the shop floor for what's going on right now, very much geared towards shop floor employees. And then as well as what it looks like in our analytics portal. So you're probably also familiar with that, but that's our system that's used for more historical or kind of deep dive analysis, looking at trends over time. So I'm, throughout the session, I'm going to assume that you have a bit of a base understanding of Shoplogix as a company and the products and solutions that we offer, namely this digital whiteboard being our real-time shop floor product, and the analytics portal being our kind of historical analysis engine, because this feature is kind of, it touches on both of these core parts of the product. After that, I'll go into a bit of, showing you what's under the hood, explaining how the actual, the logic behind this feature works, and then show you some of the more advanced options that we have to help you tailor the feature to work best for your organization. Then I'll hand it over to Adam, where we get into the exciting part, and he'll share us about some of the cool stuff on how they've been using the feature at their organization. And at the end, obviously, we'll have Q&A. Okay, so just to kick it off, the kind of tagline for this feature is that top historical speed is designed to help you identify the best sustainable run speed for each job and machine on your plant floor. I'll get more into details around how each of these things work, but just to kind of cover some of the high level key features and benefits. The first thing is that it helps give you the top historical speed insights for the current job that you're running in real time. So what that means is that on the shop floor, you can see for this current job what the best sustainable speed was that was ever reached for a job like this. And by giving this data to people on the shop floor in real time, it helps encourage engagement and focus around optimizing run speed, which is the next step in our product roadmap, because in the past, you might notice that a lot of our pieces of our product are focused around giving you insights around stoppages and idle time losses. But this is kind of one of the key things that's helping us step forward and getting insights towards losses that occur while running at suboptimal speeds. And by giving this information in real time in the shop floor, it helps engage shop floor employees. The other thing is it helps you identify the top achievable run speed for each product or product attribute. Again, I'll get more into detail around how we do this in the configuration. But what this really does is it helps you get more the data that's necessary to help you challenge and optimize your production targets. So with this information, you can get deeper insights around how certain jobs that how their speeds compare to jobs in a similar category, and use that information to challenge whether or not your current production targets are as optimal as they should be. The other thing is this new top historical speed data is correlated with our existing production data in the analytics portal. I'll show you more detail in a few slides of what that means, but the key thing here is that it helps you identify hidden losses over time. And then the last thing is that we've made the calculation very configurable. So there's a lot of flexibility and options that exist that help make sure that the calculation and what we're determining as the top historical speed is set up to do that in a way that makes the most sense for your unique needs of your organization. Okay. So the next thing I want to get into is kind of what does this feature actually look like in the different parts of our product? And the first part being our real-time digital whiteboard product. So again, I mentioned that this is the product that you expect to see with Shoplogix on the shop floor. Many of you are probably familiar with this, as this kind of really is the core backbone of our product. But really the value here with having this, the top historical speed data in our digital whiteboard product is that it helps engage people on the shop floor. So you'll notice in this picture over here on the right, that we've now introduced this red line into our machine chronological view. So many of you are probably familiar with this view, the machine chrono view, we call it. You'll notice that everything you see in these buckets down below, where they're around 250, 249, these are your production buckets that represent how much you're producing within each block of time, let's say per minute. Now you also see above, we have now introduced this red line that represents the top historical speed that was ever reached for a similar type of job that you're running right now. So basically, this gives you a continuous real-time indicator of what the best possible speed is for the type of job you're running and how that compares against your current speed in real time. Now, the reason why this is valuable, one, is that it helps engage shop floor personnel to consider and optimize run speed. So again, it starts to shift the focus more from not just about stoppages and idle, but also about speed loss, and helps to get that kind of information more ingrained in the shop floor culture and involved in your daily management systems. Through having this red line and that easy comparison between what you're producing and what you could be producing, it gives you that visual indicator of missed opportunity in real time. So basically, you could kind of interpret this as any space between these production buckets and the red line is, opportunity left on the table. That's, we could have been producing at a higher speed than we currently are, and you have that visual indicator in real time throughout your production run. And then the other thing is, if as you get engaged in the data and you have the opportunity to validate that the top historical speed is, something that was sustainable and able to be achieved, then this information could feed into more real-time speed adjustment decisions. So maybe you can see here, I'm running at 250 parts per minute, but I can see that the best speed that I've ever reached was 279. One of the things you might do is say, well, let's go back and figure out, how do we do that in the past? Or was that really a sustainable speed? Let's go back and check what did we do differently then that allowed us to achieve that speed? And maybe you've done that validation, and the next step is, okay, I can see that the best speed I'm able to reach is 279. Maybe let's increase the speed of this machine. So, overall, the kind of key takeaway here is that the focus is that we give you that visual indicator in real time that helps engage people on the shop floor, helps encourage the culture to be focused more around run speed, as well as, just idle time losses. The next thing I'll show you is what the feature looks like in our analytics portal. So basically what we've done here is we've introduced a new dimension to our analytics database. So these two new data fields have been introduced, one of them being the top historical speed and the other one being the job top speed. Now I'll quickly describe what those mean. Basically, the job top speed is the best speed that was reached for each individual job run or job instance. So, let's say you produce a job multiple times over, several weeks. Each individual job run will have one job top speed. Then we'll look at all of your job runs over a historical period, and the job run with the highest max speed, that speed will now become the top historical speed. So basically, job top speed is for each job instance, and your top historical speed is across your entire job grouping. So basically, with having this information in the analytics portal allows you to correlate it with your existing production data. And I'll give you an example just looking at this graph here. It gives you a really good visual indicator around how top historical speed works by having a comparison against some different speed metrics. So the red line in this graph actually represents the top historical speed. The purple line represents the job top speed, so the max speed that was reached in each individual job instance, and each kind of point on this line represents an individual job run. And the green line represents the average running speed from each of these job runs. So a couple of cool things that you can see from this information. One is that every time the purple line crosses over the red line, where basically that represents us setting a new speed record. So that means that we've reached a new speed within that job instance, and then that has now set the bar one level higher for our top historical speed. So this is just kind of cool because it gives you a visual indicator around how those top speed records are being set over time. The other thing that I find really valuable about this type of graph is that because this green line represents your average running speed, essentially any space you see between the green line and the red line is again another way to visualize missed opportunity. Our goal should really be to make that green line as close to the red line as possible, or in other words, make sure your average running speed is as close to your best possible speed as it can be. And the bigger the gap there, essentially the more time or money, speed you've left on the table. Obviously, the faster you're able to run in the same period of time, you're able to produce more stuff and be more efficient. So this, allowing you to have these data points let you create kind of these widgets that give you these great visual indicators. The other thing you can do with this is actually create your own KPIs. So this is an example just above in this table, showing you some of the metrics that you can actually use to quantify what your losses may have been over time by running at suboptimal speeds. For example, let's say here that we're grouping our jobs based on the job's material type. And you can see for the paper material, we have a total of 68 hours of uptime of total running time that we've been producing this type of job. Now we can see based on a calculation using the top historical speed data that if the top historical speed was used, then we would have been able to produce that within only 54.9 hours. So that basically says that we have 13.1 hours of excess machine hours used. So this is just a really cool example of how you can use the top historical speed data points in analytics to create your own formulas, to create your own KPIs, and to be able to uncover and quantify any missed opportunity. Okay. So jumping into the next section, so I've kind of shown you what top historical speed as a feature looks like in the different core parts of our product. Now I'm going to show you a little bit of kind of what's under the hood, or how the actual algorithm works. So just the kind of basic statement here is that top historical speed is an algorithm, so it's a mathematical function, and it will analyze your performance of your past jobs. We actually look 2 years into the past horizon, and it'll identify the best possible speed that was reached in every one of those job instances. That's, as I mentioned before, what is the job top speed. Then, so basically as a kind of overall overview, we start by analyzing the last 2 years job instances. Each one gets its own job top speed. We then group the jobs by some common variable. So this could be a job name, it could be the product type, it could be a SKU, material type, it could be the mold in an injection molding press. I'll show you where the information is stored. It's actually in our job filters within the Shoplogix job object. But essentially what you need to know is that it allows you to define how you want to group your jobs by some common variable. And then that will allow you to identify the top historical speed for each job grouping. So that's sort of the high level overview of how the calculation works. But I think to further understand it, it helps if I can get into the job grouping options to show you what options you have available. So the first option is the job name. So I'm showing an example of a job modal over on the right here. So this is, if you open the job list view in Shoplogix and you drill into one specific job instances, this is what you'll see. So the job name is one of the grouping mechanisms that you can use. Now, this is really going to be useful if you're running an operation where you produce the same job name multiple times. If your job names are unique, like for example, a unique batch number, then you would not want to group your jobs by the job name. But if your job name is something you repeat over and over, let's say 2-liter plastic bottles, and you produce that job many times over time, then maybe that's what you will want to use as your job grouping. And that will make it so that every job name will have one top historical speed. It'll analyze all runs from that job name and identify one top historical speed. Now, the other option that you'll see here, which actually I think most people are going to find most value out of using this option, is the job filters. So if you're not familiar with the job filter, basically it's an open user-defined field that you can store any type of information that you find relevant to that specific job. So one thing can be the material type. Another could be the SKU or the product type, or any other information that is related to this job. And the reason why these job filters are valuable is once you populate these across all of your different job instances, then you can start to analyze your jobs by these filter values. So for example, you can analyze jobs by the type of material that they contain. And you can look at different jobs that may have the same material. So the reason that this is valuable to use for the top historical speed grouping is once you pick one of these values, it'll basically group all your jobs by that value. So let's say, for example, we choose filter 1. It'll group all jobs that have the paper material. It'll group all jobs that have canvas, all jobs that have plastic. And then for each job grouping, you'll get one top historical speed. So I'm assuming that many of you'll find the job filter method to be the most useful for configuring this. But for each machine, you have the option of how do you want to group your jobs to calculate the top speed. And these are two of the key ones. The last one option that you have is what we call no grouping, or a machine level calculation. And essentially what this means is that you'll get one top historical speed for each machine. So it'll ignore the job names, it'll ignore the job filters, and every machine will just get one top historical speed. So it'll analyze all job runs from that machine over time and pick the one that had the best performance. So that's just an overview of the grouping options that you have as a kind of an extension of how this feature works. And then the last thing I'll show you before I hand it over to Adam is the advanced calculation options. So you'll notice that we've been kind of getting more into the technical and how it works stuff. This is the last thing I'll show you in regards to that. But the key thing here and why I want to show you this is that it actually is a big contributor into one of the main value points of this feature is that we help you identify the best sustainable run speed for each machine and job. And the key word there is sustainable, because we actually have a few other kind of calculation options that help you define what sustainable means for your operation. So basically, the way it works is that the top historical speed algorithm will look deeply into the past of all your job runs and look at every single minute of production through every run. And basically, for it to consider a specific period of time as relevant for whether or not it can be the top historical speed, it must be sustained for at least X minutes and remain within a Y% speed tolerance. So these are the two fields that you have now at your disposal. One is that you can say, I want to only look at running periods where I was able to produce for at least 5 minutes, and the speed within that 5-minute period did not change more than 10% plus or minus. Now, that calculation window and the speed tolerance are something that you can define for each machine. But the key thing and why this is valuable is it helps ignore things like signal spikes. So you may notice sometimes the Shoplogix, if you have a connection issue between a machine and your connector PC, you could see when that connection comes back online, you'll get a spike in production. Using this calculation though, that spike would be considered a change that's far out of tolerance and would basically result in ignoring that period. The other thing that we have is that if you were to go from running to idle, that would also be considered a large change in your tolerance of speed, which results in us being able to ignore idle periods. So really, it's only looking at periods that are able to sustain a running speed for a specific period of time. A couple of tips when it comes to calculating or defining which option is best for you. When it comes to the tolerance, we do recommend that if you're running a high-speed machine, that you pick a lower tolerance. And if you're running a low speed machine, that you pick a higher tolerance of speed change. The reason there is that you can imagine if your machine is producing 1 or 2 parts per minute, then a change from 1 to 2 or 2 to 3 is a pretty significant percentage change, like 50 to 100%. Versus if you're producing at 500 parts per minute and you change from 500 to 505, that's only a 1% change. So if you still want to if you're running on fast machines, it is recommended to use a low tolerance to avoid major swings in speed. And similarly, if you're running a slow machine, it's recommended a high tolerance to avoid throwing out periods that may have changes from like 2 to 3 parts per minute, for example. And a couple of things that are not on the slide that I also want to call out. One is you may be wondering, what if I am producing fast, but I'm producing a lot of scrap? We do have the ability to look at the quality of the product. So basically whether it's total production versus good production. I think I see a question related to that now, so hopefully this answers that. So you can basically say, I want it to calculate based on all production, ignoring whether they were good parts or not. Or you can say, I only want it to calculate based on good production, which will basically ignore part counts that were resulting in scrap. So it'll only look at good production counts. And then the last thing that we also have as an option is if maybe you had a specific job run in the past that was a serious outlier, the performance was not something that you would be able to sustain, or there's a reason why you don't want that to be part of the calculation. We have the option inside every job instance to flag it as to be hidden from the top speed calculation. So you can basically use that to manually select if there's specific jobs you don't want to be included as part of this analysis. So that's pretty much it in terms of like the background around how it works and what it looks like in the whiteboard. Hopefully you found that overview educational.